Section 1, Waves and Electromagnetic Spectrum. It is a long swim, but now you're resting on the swimming raft in the lake. You hear the water lapping gently against the raft as the sun warms your skin. Suddenly, a motorboat zooms by. A few seconds later, you're bobbing wildly up and down, as the boat's waves hit the raft. Although the speedboat doesn't touch the raft, its energy caused waves on the water. Then the waves move the raft and you. You can see and feel the waves when you're on a swimming raft. But did you know that many other kinds of waves affect you in every day? Sound is a wave. Sunlight is a different kind of wave. Light, sound, and water waves may seem very different, but they're all waves. What is a wave? Waves and energy. A wave is a disturbance that transfers energy from place to place. In science, energy is defined as the ability to do work. To understand waves, think about the swimming raft. A wave that disturbs the surface of the water will also disturb the raft. The wave's energy lifts the heavy raft as the wave passes under it, but the disturbance caused by the wave is temporary. After the wave passes, the water is calm again, and the raft stops bobbing. What carries waves? Most kinds of waves need something to travel through. Water waves, for example, travel along the surface of the water. A wave can even travel along a rope. The material through which a wave travels is called a medium. Gases such as air, liquids such as water, and solids such as rope all act as mediums. Waves that require a medium through which to travel are called mechanical waves. Some waves do not require a medium to travel through. Light can travel and carry energy through empty space. Waves that can travel without a medium are called electromagnetic waves. How do waves transfer energy? Energy is required to make a wave. Mechanical waves are produced when a source of energy causes a medium to vibrate. A vibration is a repeated back and forth or up and down motion. When a vibration moves through a medium, a wave results. When waves travel through a medium, they do not carry the medium with them. Why doesn't the medium travel along with the wave? All mediums are made of tiny particles. When a wave enters a medium, it transfers energy to the medium's particles. The particles bump into each other, passing the wave's energy along. Reading checkpoint. What is a vibration? Figure 2, amplitude, wavelength, and frequency. The basic properties of all waves include the amplitude, wavelength, and frequency. A wave that moves a rope up and down in a direction perpendicular to the direction in which the wave travels. Developing hypotheses. How could you increase the amplitude of a wave in a rope? How could you increase the frequency? So up, crest, the direction of the wave. Down, and trough. The wave in a blue rope has a smaller amplitude than the wave in the yellow rope. Amplitude, meaning the distance between the height of the wave and the rest position, which is the dotted line. The trough is the distance below the rest position, and the crest is the position highest above the rest position. Properties of waves. Waves can carry a little energy or a lot. They can be short or long. All waves, however, share certain properties. The basic properties of waves are amplitude, wavelength, frequency, and speed. Amplitude. When you make a wave on a rope, the rope itself moves up and down or from side to side, perpendicular at a 90-degree angle to the direction in which the wave travels. The high point of a wave is called the crest. The low point is called the trough. The distance the medium rises depends on the amplitude of the wave. Amplitude is the maximum distance that the particles of the medium carrying the wave move away from the rest position. For example, The amplitude of a water wave is the maximum distance a water particle moves above or below the surface level of calm water. You can increase the amplitude of a wave in a rope by moving your hand up and down a greater distance. To do this, you have to use more energy. The energy is transferred to the rope. Thus, the more energy a wave has, the greater its amplitude. Wavelength. A wave travels a certain distance before it starts to repeat. The distance between two corresponding parts of a wave is its wavelength. You can find the wavelength of a wave by measuring the distance from crest to crest, as shown on figure 2, or you can measure from trough to trough. Frequency. Wave frequency is a number of complete waves that pass a given point in a certain amount of time. For example, if you make waves on a rope so that one wave passes by every second, the frequency is 1 wave per second. How can you increase the frequency? Simply move your hand up and down more quickly, perhaps 2 or 3 times per second. To decrease the frequency, move your hand up and down more slowly. Frequency is measured in units called hertz, the symbol Hz. A wave that occurs every second has a frequency of 1 hertz. If 2 waves pass you every second, then the frequency is 2 per second, or 2 hertz. The hertz was named after Heinrich Hertz, the German scientist who discovered radio waves. Speed. Different waves can travel at different speeds. The speed of a wave is how far the wave travels in a given amount of time. If the medium that a wave travels through does not change, the speed of the wave is constant. The speed of a wave can be found by multiplying its frequency by its wavelength. Thus, you can increase the speed of a wave by increasing either the wavelength or the frequency. Looking at the image now. Wavelength is the distance from crest to crest, or from trough to trough. The wave in a green rope has a shorter wavelength than the wave in the yellow rope. One wave in the yellow rope passes this point in 1 second, so the frequency is 1 hertz. 2 waves in the green rope pass this point in 1 second, so the frequency is 2 hertz. Figure 3. Fields are at right angles, 90 degrees from each other. We have an electric field and a magnetic field, and this is the direction of the wave following the arrow. Figure 3, electromagnetic wave. In an electromagnetic wave, electric and magnetic fields vibrate at right angles to each other. Interpreting diagrams. What is the angle between the fields? Reading checkpoint. In what unit is the frequency of a wave measured? What is an electromagnetic wave? Waves in water and ropes have 2 things in common. They transfer energy, and they also require a medium through which to travel. But electromagnetic waves can transfer energy without a medium. An electromagnetic wave transfers electrical and magnetic energy. Key idea. An electromagnetic wave consists of vibrating electric and magnetic fields that move through space at the speed of light. Producing electromagnetic waves. Light and all other electromagnetic waves are produced by charged particles. Every charged particle has an electric field surrounding it. When a charged particle moves, it produces a magnetic field. When a charged particle changes its motion, its magnetic field changes. The changing of magnetic field causes the electric field to change. When one field vibrates, so does the other. In this way, the 2 fields constantly cause each other to change. The result is an electromagnetic wave as shown in figure 3. Notice that the 2 fields vibrate at right angles to each other. The energy that is transferred through space by electromagnetic waves is called electromagnetic radiation. Electromagnetic waves do not require a medium, so they can transfer energy through a vacuum or empty space. This is why you can see the sun and stars. Their light reaches Earth through the vacuum of space. Speed. All electromagnetic waves travel at the same speed in a vacuum, about 300,000 kilometers per second. This speed is called the speed of light. At this speed, light from the sun takes about 8 minutes to travel the 150 million kilometers to Earth. When light travels through a medium such as air or water, however, they travel more slowly. What is the electromagnetic spectrum? All electromagnetic waves travel at the same speed in a vacuum, but they have different wavelengths and different frequencies. As the wavelength decreases, the frequency increases. Waves with the longest wavelengths have the lowest frequencies. Waves with the shortest wavelengths have the highest frequencies. The amount of energy carried by electromagnetic waves increases with frequency. The higher the frequency of a wave, the higher its energy. The electromagnetic spectrum is a complete range of electromagnetic waves placed in order of increasing frequency. The full spectrum is shown in Figure 5. Microwaves, radio waves, infrared rays, ultraviolet rays, X-rays, gamma rays. Short wavelength, high frequency on the right. Long wavelength, low frequency on the left. The electromagnetic spectrum is made up of radio waves, infrared rays, visible light, ultraviolet rays, X-rays, and gamma rays. Electromagnetic waves that you can see are called visible light. Radio waves. The electromagnetic waves with the longest wavelengths and the lowest frequency are radio waves. The very long wavelengths are used for broadcasting AM and FM radio and television signals. Microwaves. The radio waves with the shortest wavelengths and highest frequency are microwaves. These waves are used in microwave ovens to heat your food, but they're also used in cellular phone communications and in radar systems. Infrared rays. If you turn on a burner on an electric stove, you can feel it warm up before heating element starts to glow. The invisible heat you feel is infrared radiation. Infrared rays are used in heat lamps. Here's this Figure 4 radar gun. Radio waves are used to find the speed of moving vehicles. Reading checkpoint. What is the electromagnetic spectrum? Continuing. Visible light. Visible light is a small band with a very broad electromagnetic spectrum. The wavelengths of visible light vary from 800 nanometers or 0.000008 m red light to 400 nanometers or 0.000004 m the violet light. The main colors of visible light in order from the largest to the smallest wavelengths are red, orange, yellow, green, blue, indigo, and violet. They form a continuous spectrum. Ultraviolet rays. Electromagnetic waves with wavelengths just shorter than those of visible light are called ultraviolet rays. They carry more energy than the visible light. Small doses of ultraviolet rays are useful. For example, ultraviolet rays cause skin cells to produce vitamin D, which is needed for healthy bones and teeth. However, too much exposure to ultraviolet rays is dangerous. It can cause skin cancer and damage to your eyes. If you apply sunblock and wear sunglasses that block ultraviolet rays, you can limit the damage caused by ultraviolet rays. X-rays. Electromagnetic waves with wavelengths just shorter than those of ultraviolet rays are called X-rays because they have more energy than ultraviolet rays. They can penetrate most matter, but dense matter such as bone or lead absorbs them and does not allow them to pass through. Therefore, X-rays are used to make images of teeth and of bones inside the body. Too much exposure to X-rays, however, can lead to cancer. Gamma rays. The electromagnetic waves with the shortest wavelengths and the greatest amount of energy are gamma rays. Gamma rays are the most penetrating of all electromagnetic waves. They can be used to kill cancer cells inside the body. Reading checkpoint. What are the colors of visible light?